So we're going to talk about distributive property versus factoring. We're really good in distributive property, and this is just beginning. X plus 3 multiplied by x plus 2. We've seen this before. We know how to multiply. Just a reminder that they had two parts. We have factor number 1 and factor number 2. We take first factor and multiply each term in a second factor. So we do that with the green. And then second term in the first factor, we multiply out with both terms in a second. X times x plus 2 times x and 3 times x plus 3 times 2. And now we can simplify that even further to finish up. So using distributive property, we end up with a trinomial because it has 3 terms, 1, 2, and 3. I just want to point out what's interesting is that when you look up sections up here, first term and second one, there's a 3 and 2. There's a 3 and 2 here and 3 and 2 here. That's something we're going to use later on. But let's just make sure that we do distributive property. We did distributive property here. And factoring is pretty much going backwards, inverse procedure. So distributive property, step by step. Factoring is going back to end up with 2 factors, factor 1 and factor 2. Now we have the relationship between distributive property and factoring. They're kind of inverse of each other. So let's focus on this middle step. I am just going to pull it here on the side. Very interesting and important section to remember is that 2x plus 3x, notice these 2 plus 3, we're adding them, and these two same numbers we are multiplying here. And those are part of our factors. So we're going to use this knowledge when we walk backwards, when we do factoring, that this 5x has to be broken down in a number that could be added to get the x number, and then two same numbers that could be multiplied to get freestanding number or constant. Let's factor this polynomial out. We know that this is going to be final answer, but we want to know how to get there. So first step, here's the first step. We always have to focus on the constant. That's going to be our key. So the constant, remember how we said that we have to find 2 numbers. If you add them, you get x. If you multiply them, you get constant. So I can find 2 factors of 6. It could be 2 times 3, or it could be 6 times 1. They're both correct factors. So one of these doesn't fit. And we're going to prove this one. This one does not fit. How so? Well, I know that if I take 6 times 1, it's 6, which we get constant. But we also have to do 6 plus 1, same number, to get x part, coefficient by x. And that is not the same. We need 5x. So this one doesn't work. This one has to work. 2 times 3 is a 6, exactly what we need. But the same numbers, 2 plus 3, it is 5. That's exactly what we need. Here it is, 5x. So 5x is sectioned out, broke into 2 numbers. 2x plus 3x will give me 5x, and 6 is broken down into factors, 2 times 3, just like we done before. And now all we need to do is combine like terms. But we're going to do this. We're going to do it in such a way that it's convenient to us. We're going to combine these 2 and these 2. Usually works that way. First 2 terms, I'm looking for common factor. I see that's x. This one has x. I can rewrite it like this. X times x. And this one has x. So common factor between these 2 is x. So what's left here? If I take 1x is left. And the second term, I have x already, so 2 is left. That's done. Moving on to the second part. I'm looking in 2 terms. What factor do they have in common? I see 3 in both, so it'll be 3 times 3 multiplies x, and here 3 multiplies 2. So let's stop there to observe. We have 2 terms, and each term has 2 factors. Factor 1, something times something. Factor 2, something times something. 2 factors here, 2 factors there. But compare those two, you will say that they have 1 factor in common, x plus 2. Both terms have same factor. And now we are ready. We are ready for last step. What they have in common? X plus 2. So x plus 2 in a first term multiplies x, and x plus 2 in a second term multiplies 3, and we are done.